Okay, so what should we do for the first problem? There are 2 logs on the left side. You can what? Using the multiplication property to combine it as one single log, right?
Yes.
So it will become a single log to the base 4 of x plus a times x plus 6. Okay? So far, so good? And on the right-hand side, I just copy it down, right? This is the what? Product rule. Okay. Now, this is log that is log with the same base. And we said already, logarithm is 1 to 1. Is that right? So, if it's 1 to 1, the output are the same, then the input must be the same. This is a 1 to 1 property. Yeah?
Okay.
Right? It's just like if you say, this function is 1 to 1. Okay? This is x. That is a. Okay? So the output here is f of x. The output here is f of a. Is that right? Yeah? This is a function, right? Now, if you tell me that they are equal, well, this function is 1 to 1, right? Different input will go to different output. Now, if you tell me the output are the same, wow, then the input must be the same. Does it make sense? Okay? Because for 1 to 1 functions, it means what? Different input would correspond to different output. Okay? So don't tell people that you are canceling or dividing. No, it's not. It's because what property? Say out loud. 1 to 1 property. What is 1 to 1? The log function, right? The logarithmic function is 1 to 1. Okay, so this is piece of cake for you now. What would you do? This is, yeah, you FOIL it. You get x squared and then plus 14x and then plus 48 equals to 3. So x squared plus 14x plus 45 equals to 0. And then continue. X plus 9 times x plus 5 equals to 0. So x equals to negative 9 or x equals to negative 5. Okay? And then you check. All right. Yeah, we have to check. What do we check for? We need to check the domain of the logarithmic functions. Okay? We have to make sure this has to be greater than 0. That has to be greater than 0. Right? Okay? So, yeah? That is the first check. So, for x equal to negative 9. Uh-oh. Well, negative 9 making them both greater than 0? No, because negative 9 plus a is negative 1, less than 0, right? Negative 9 plus 6 equals to negative 3, less than 0. So sorry. What about for x equal to negative 5? Well, negative 5 plus 8 is what? 3. Is that greater than 0? Yes. Okay? And negative 5 plus 6 is 1. Is that greater than 0? So it's okay. Okay doesn't mean it's solution. It's just possible solution, right? What is the second thing we need to check? We have to check what? The equation, true or not, right? So you only have this to check now. You just need to plug in negative 5 into the equation. So log to the base 4, negative 5 plus 8, plus log to the base 4, negative 5 plus 6. You ask yourself whether it equals to log to the base 4 of 3, right? What is this? This is log to the base 4 of 3 plus log to the base 4 of 1. And you know what is this? 0, right? Is that equal to log to the base 4 of 3? Yes or no? Yes, because this is 0, right? Yes. So you got the check done. Okay? So negative 5 is your solution. And you answer the question using solution set. Okay? How many papers are you grading got it right? Raise your hand. Very nice. Very nice. They didn't check it? If they did not check it,
What if we didn't check part 2?
that is so important. How could you not to check part 2? You have to check both parts. Okay?
Memory?
Mental math? Sorry? Okay. It's not even making it in the domain. It doesn't make sense to check anything. It's not even in the domain, right? Okay. All right. Somebody say that. Negative 9, if you check. All right, let's do that. Negative 9 plus A. Negative 9 plus 6. Okay. The question is, this is log to the base 4 of negative 1. You don't have this. This is not even a number. You cannot even talk about that. Okay? So you do not even, it's not even qualified to check this. It's not even, you know, we cannot have this for log function. Log has to have the domain which consists all the positive numbers, right? So no way. You don't even qualify to, you don't need to, right? Because you cannot even sit here, okay? 10 points? Okay. So I'm going to tell you how you grade your paper. Having this is 2 points, okay? Using the product rule, 1 point. Getting this is 2 points. Getting this property is 1 point, okay? And then solving all this is again 2 points, okay? Getting x equal to negative 5 or x equal to negative 9. And then the checking was 2 points, okay? So it means this checking is 1 point, this checking is 1 point, all right? And I said already, today no mental math. You have to check. You have to show your brain work, okay? All right. Does it make sense now? Okay. How many of you got full credit? Okay. So you need to learn more. Okay. You need to learn more. Okay. Now I would like to show you the second problem. Okay? Where is my x? X is in the exponent, or you say in the sky. How do you bring it down? Well, we only have that if we have logarithmic expression, right? So, well, this is exponential. So we are thinking, well, they are equal. Okay? This guy equal to that guy. Okay? And I'm going to apply the same thing and it should be equal, right? Because I'm taking the same action. Are you with me? What is the base that I'm using for this log? 10. Can I use ln function? Yes. Can I use log 2? Log to the base 2? Yes. As long as it's the same, right? Why I am choosing base 10? Why I may choose ln? Because on your calculator, there are only 2 bases. One is base 10, The other one is base e, which is ln. So it's very, very common that people take log on both sides. Is that okay? Okay, or you can take ln on both sides. So let me take ln this time because this is something that you not very familiar with, okay? All right, I'm taking log with the same base on both sides. And the reason is why I want to do this? Because by using the power rule, the power can be taken to the front. This is the power. Come out. Right? So what do you have now? You will have x times ln of 0.4. That will equal to parentheses, right? Because as a whole is your exponent times what? ln 2. Does it make sense? What is ln 2? Well, you just say, Dr. Chen, it's just a number. Use your calculator, right? It is a number. It is a number. Okay? ln 2 is a number. What is ln 0.4? Again, it's a number. Am I correct? What do you want to solve? You want to solve for x. Am I correct? So remember, this is just a number, like a 2 or 3 or 4. So it's like a 2x or 3x or something. Remember? Here, this is a number. So you have to treat it as a number and then solve for the variable x. Does it make sense? So can I distribute this? Yes, it will be x times ln 2 minus 3 times ln 2. Does it make sense? This is my x term. And here is x times ln 0.4. This is also my x term. I have these two x terms. I need to combine like terms, right? Okay, so maybe you would like to combine them all to the left-hand side. So you subtract this term on both sides. Then what do you have? You will have factorial x. It will be ln 0.4 minus ln 2 equals negative 3 ln 2. Right? How do you find x? You just divide this on both sides. So x equals to negative 3 ln 2 divided by ln 0.4 minus ln 2. That's it. This is the exact solution. I didn't use any calculator. In my mind, we all know this is just a number. This is just a number. Yes? Yes, we will do more examples on this. Okay. Approximation. What will be the approximation? Well, using your calculator then. Okay? Today I didn't, but yeah, on the test, you will have to answer in exact solution form and also in approximation form. Can I have all of you using your calculator? Can you calculate this number, everybody? Okay, negative 3 times ln 2. Divide by the whole thing here. Remember, this is a whole denominator. So when you use your calculator, remember to put parentheses, right? So it means that it's all together. And the answer is 1.292. Okay? X is approximately 1.292. Okay.
So on the test, you want us to write that?
On the test, it will be explicitly say answer in those two different forms. Yes. Yes. Yeah. Okay. So this one, I will not count it, okay? Because probably you are not that, familiar. Even though that you are using the log idea, but it was one step, right? If I start with this, all of you know how to do it, right? If this is a problem, if I give you this as a problem, then all of you know how to do it, right? So what you didn't know is when you see the exponential equation, okay, the variable when they are in the exponent, then you would like to apply log on both sides. Okay? And they still equal, and then use the power rule. You use the power rule to bring down the exponent.
You should ask some of these questions tomorrow.
Okay, I take your advice. Take ln on both sides. Okay. So make sure that you get 100, okay? All right, so this quiz, just 10 points. Can you just give a point here? How many out of 10? Okay? How many out of 10? Okay, pass your paper quickly. And we're going to do more.
I don't know how to put it into my calculator.
Can I have all of you have your calculator? Do you have your calculator with you? Yes. Yes. Can I have all of you take out your calculator and calculate that number? Of course. This is a must. I said already. What is must? Log, exponential, because it's new. Okay? This is a very, very practical in our life. Okay? And a lot of time we may not ask this. We may ask that, oh, Jerry has $500. Okay? How long will it take to triple his money? Okay? Or you want to invest in some kind of mutual fund. How long will double his money? Yes. It will get 8 months. Can I show you how do I get 8 months? Yes, this is. All right, now everybody listen. How do I get, people asking, how do I get this 8 months? How? You get 17.62 years, right? So you know, not just 17 years. It's more than 17 years. 17 years and some months, right? It is not yet 1 year. It's just 0.62 year. So 0.62 years and 1 year has 12 months. Right? This is the unit transfer. Okay? You try to change from year to month, and every year has 12 months. Okay? So you multiply this ratio, 12 months for 1 year, times 0.62 years, then you will get 7.44 approximately months. So if you want to get that money, it has to be more than that, which is 8 months. Okay? All right? No. I'm just saying when you talk to the bank, there's no way that you can say, oh, today is 7.44 months. You have to give me money. No. In the bank, no, there's no rounding up here. You have to use your common sense. Excuse me. Why we have to pick up 8 months, not round down to 7? Because if you round down to 7, say 7 months, his money is less than 1,200. When you reach to 7 months, his money not yet 1,200, right? He has to have 7.44 months to get 1,200. Okay? And in the bank, usually they will count by month, not by day. Okay? So you have to exceed that 7 months. Cannot be 7 months. 7 months, not yet 1,200. No problem. So if I say I'm going to ask the second question, when Jerry will have double of the money, then what would you do? What is double of 500? 1,000. 1,000 is double. Then you will change this to 1,000, right? But remember, yeah, you will change 1,200 to 1,000. But remember, you would like to what? Divide both sides by 500, right? Yes? So then making the coefficient to be 1. So when you divide by 500, what do you have here? It will be 2. So what does it tell us? It will take the same time for anybody to double the money. If you have $1, you're expecting to have $2. Or you have 1 million and you expect to get 2 million. It takes the same time. Does it make sense? Because you have P here, and here you have 2P. and you divide both sides by P. Does it make sense? Not at all. What do you mean by double the money? What do you mean by double the money? I will show you here.
So you would have to multiply 1,200 by 2.
I will show you here. Head it back. Like this is. P is A is P times 1 plus R over N to the power NT. Do you see that? Okay? I have 1 million. And I'm hoping to get 2 million. Okay? How do you solve this? I said already, I would like to have this to be 1, so I would divide both sides by what? 1 million, right? So when you divide both sides by 1 million, what do you get here? 2. So you get 2 equals to this. Right? Now comes the other person. He said, I only have 100. So for that person, he only has 100. And he would like to double it. What is double for 100? 200, right? So to solve this, you would like to divide both sides by 100. Thank you. So that you can get coefficient 1 here. So you get the same equation, right? So for a person saving from 100 to 200, the other person, like me, I wish I have 1 million, from 1 million to 2 million. It takes the same time. So what does it tell you, my dear friends? You want to save money as early as possible, okay? This person saved $1 million when he was 25 years old, okay? And that person saved 100 when he was 100 years old. 25 years old. Okay? It takes them the same time to double their money, but this guy only up to 200, but this guy already, what? Have 2 millions, right? You want to do investment early, you want to save your money early, or if you want to do any insurance, life insurance or something, people will try to do it early because that compounding makes a lot of difference, okay? This is life learning. You have to know why you learn this. Why you learn these exponential functions. It is to help you do a good and early financial planning, okay? Try to save money early. Compounding makes a lot of difference, okay? All right.